A power of 2 is a number like 1, 2, 4, 8, 16, and so on. Look at 16 in binary, 1, 0, 0, 0, 0. Notice something special. There is exactly one bit set, and the rest are zeros. Every power of 2 looks like that. Can we test for it in one clean line? Here is why the trick works. A power of 2 has a single 1 bit and nothing else. Now subtract 1. That lone 1 bit turns to 0, and every position below it becomes a 1. So the two numbers n and n minus 1 share no 1 bits at all. When we bitwise in them, we get 0. For any other number which has more than 1 bit set, the higher bits still overlap, so the n is not 0. We just guard against 0 itself, since 0 is not a power of 2. First, we make sure the number is positive, because 0 and negatives are never powers of 2. Then we check that n, and n minus 1 is 0, which is true only when the number has a single 1 bit. Let's test a handful of numbers, some powers of 2 and some not. The function takes a single number n to test. It must be positive, and n and n minus 1 must be 0, meaning only 1 bit is set. Now let's test it and hit run. "16 is yes, 1 is yes, 8 is yes. 6, which is 110, has 2 bits set, so it is no. And 0 is no, because 0 is not a power of 2. There is no loop here. 1 subtraction, 1 and 1 comparison. So it runs in constant time and constant space, however large the number. Two easy mistakes to avoid. First, without the positive check, 0 and 0 minus 1 would sneak through as a false yes, so always guard n greater than 0. Second, remember 1 counts, because 1 is 2 to the power 0.